So you add the x, the y, and the z's. That's what you get. And then to find the magnitude of the vector, square them up, add them, take the square root. Well, I suppose we talked about this, but that's a review because it's so important. If you have a vector A, you resolve it into two components, A cos theta and A sine theta, and therefore AB plus BC is AC, isn't it? Isn't that the sum? It works either way. You can see it as a single vector split up into two, or two vectors giving the resultant, because they are opposite functions. Okay, that's our second question. So I've resolved V2 into two components, V2x and V2y. V1 does not have a y component. What do I do next? Find the components. How much do you get V2x as? Shouldn't it be 8.5 cos 45, right? Okay, and V2y should be 8.5 sine 45, right? And what is V1x? 6.6. If you have drawn the diagram, you need not put the negative because the direction is already shown in the diagram. Because remember, two negatives make a positive, right? Okay, be careful, that's all. So V1x is negative 6.6 units because that's not in the diagram. I'm writing it. V2x is 8.5 cos 45. That's 6 units. And because cos 45 and sine 45 are the same, you will get the same thing for the y component. So you got 6 units. What do you do next? Come on. Add the x components. When you add the x components, you're going to get 6 minus 6.6, which is negative 0.6, isn't it? Negative 0.6, and the y component is 6. Next, to take the magnitude, square both up, add them up, take the square root, you get the answer. Such an easy thing. And this almost becomes 6 units. I mean, it's not going to be exactly 6, but this thing is so small, 0.6 is so small that you almost get the same, right? And then when you find theta, tan theta is what? Take a look at the diagram now. Everybody, 1 second please. Take a look at the diagram. Do you see the blue vector there?
Yes.
That is the resultant of the two. Do you see that? Do you know why that's the resultant? Look at what color is that? Is it pink? Yeah, look at the pink. Isn't that the x and the y? Remember, the x was how much? The x was negative 0.6. That's why you have that such a small one. Do you see that? Negative 0.6. And the y is 6. And so the resultant is given by the blue vector. Are you getting what I'm saying? And don't you see that from the diagram it appears to be almost the same in length as the pink one? That's why both are 6. And how do you find the angle now? I'm trying to find the angle which I got as 84 degrees. You can see. So the triangle is on the other side, and therefore tan theta would be 6 divided by 0.6. That's why it's 84 degrees. So when you specify the angle, you'll have to say it's 84 degrees with the negative x-axis, isn't it? With the negative x-axis. So you have the vector resolved into its two components. 735 cos 41.5 gives you 550 kilometers per hour, right? And then the other component is 735 sine. Wait a minute. Hey, why did I make a mistake? But I realized that I made the mistake, not you. Okay, anyway. I made a mistake. Look at that. That should have been cos. The other one should have been sine. Too bad. I was sleepy. Anyway.
Or you could use the complementary angle.
Yeah, but anyway. That's a mistake, what I've written. Okay, give me the numbers. I'll change that.
48.5 for the angle.
I know. I mean, give me the components.
47.
487 and I have to redo this whole thing again. Oh, so 487 here and 550. Okay.
No, 47.
Yeah, I mean, switch. So in the B part, you multiply that with 3 and you would get it. Don't copy what's on the screen. It's completely wrong. I was not drunk, but I made a mistake. Okay. It happens. So you multiply, you get those two, isn't it? Yeah. So you would get along the west as 1650, and along the north, what would you get? Okay. That's not tough, except that. I'm mad.
So it should actually be...
Yeah, switched. Yeah, it should be switched. Okay, that was number 3 now. Projectiles. Now, we cannot do problems until I tell you this. And this is now time to pay attention again. So I will give you a 5. You have a vector, velocity. You resolve it into 2 components, cos and sine. Is that clear? And this would be the path taken by the projectile. And surely, what kind of a geometrical figure is that? Okay? And we can mathematically prove that it's a parabola at the end. We will show that it is. Because every conic section, you know what conic sections are? Circle, ellipse, and all this. They have equations. So at the end, we'll be able to mathematically prove that that's the conic section represented. We'll get to that. I told you we have to find out 3 quantities. What are the 3? First, let's find the maximum height. Now I need your cooperation. To find the maximum height, which of these 2 components would you use? V cos theta or V sin theta? Remember, they're independent of each other. We're trying to find maximum height. So surely, when you take the initial velocity, you would take it as V sin theta. And what's the symbol for initial velocity? V naught. So you would write V naught is equal to V sin theta. All right, I just showed the height and the range and all that. First, we're trying to find the maximum height. And to find the maximum height, you take the initial velocity. Now it's a little bit slow. Oh. Okay. I decided to write when I was teaching you. I thought I had written. So help me out with this. We have to write together. V naught is, come on, V sin theta. What else do you know? What's the acceleration? Negative G. Okay, that's 9.8, but I don't want to use numbers yet. Wonderful. We're looking at maximum height. What is the velocity when it reaches C?
0.
We're talking about the vertical velocity, right? What is the vertical velocity at the maximum height?
0.
Everybody agrees? Yes. So, the final velocity, the symbol is V, is 0. What else do we know? Because we need 4 quantities. We got 3. What else do we know? What we're trying to find. What are we trying to find? Well, I'll call it Y. Instead of X, I'll call it Y. Why should I call it Y? Because it's along the Y-axis. You got the 4 quantities? Tell me the equation that you can apply. No, you need to look at the quantities and tell me which equation to use. I suppose this is the equation that you were telling me about, right? Substitute into that, rearrange, simple math. Well, the plus is going to become negative. Is that right? The positive becomes negative because A is negative G. Then rearrange that to make Y the subject. So 2GY is equal to V squared sine squared theta. And so what's y? Y is divided by 2g. That's the final equation. All right, time of flight. What's the initial vertical component? What? What did he say? The initial vertical component is 0? Somebody said 0. Okay, anyway, I was dreaming maybe. The initial vertical component, V0, is V sine theta, right? Okay. What's A? Negative G. What are we trying to find? Time. What else do we know? He says the displacement would be 0. Can you explain that to the class?
Once it goes up, it comes back down.
So we're looking at the vertical displacement. And since it lands back on the same horizontal level, the vertical displacement is 0. It started from here and ended up here. I know there is a horizontal displacement, but I'm looking at the vertical displacement. Isn't it 0? Because if it had started from the ground and landed back on the table, what was the vertical displacement? The height of the table. Wait a minute. If it had started from the table and landed back on the ground, what was the vertical displacement? Negative the height of the table. Are you listening to me? Okay. But in this case, the vertical displacement is 0. Okay. And that means y is 0. Tell me, which equation could you use? What is the equation that relates these four quantities? You take your time. Come on. The king? Surely. So put it there. And isn't this the equation? V naught t plus 1/2 a t squared, right? Plug it in. 0. Minus half GD squared. Simple math. So you take that to the other side, becomes positive. 1/2 GT squared is t. Can I cancel one of the t's? I can't, right? Because you have t squared there and t there. And then rearrange and you get the equation. So t is equal to 2 goes to the top, 2v sine theta divided by g. That is the equation for time of flight. You got it? All right. Next, the last quantity that we have to find is the horizontal distance. Which component would you use for that is a silly question, but I'll ask you anyway. You're trying to find the horizontal displacement, so which component are you going to use? X component. And what do you know about the X component? What do you know about the X component? It's constant. The X component never changes, right? Which equation can you use if the velocity is a constant? There's only one equation you can use if the velocity is a constant to find the displacement. To find the displacement, which equation will you use? Don't give me that look.
X equals V over T.
So V over T? We multiply by T.
Yeah.
That's what you meant. So all you can do now is, to find the displacement, you multiply the constant velocity with the time. Shall we? Okay. So we're going to find the horizontal, so we'll call it X is equal to V cos theta. Horizontal component is V cos theta, right? And the time is actually the time of flight, which we got just now. So it will be V cos theta multiplied by, what was the time of flight? Wasn't it 2V, help me out, sine theta by G, was it? Because the time was 2.
Right.
Okay. Now take a look. What do you get? Do you see the v squared there? And do you see 2 sine theta, cos theta? And do you remember that 2 sine theta, cos theta could be something else in math? Anybody? 2 sine theta, cos theta. You can take those together and write it as... Somebody said it, sine 2 theta, correct. So x is v squared. Why am I shouting? I don't know. Now that's a problem, because in one of these formulas you have sine squared theta. Go back and look at the maximum height. In that formula you had sine squared theta. You notice?
Yeah.
In this equation you have sine 2 theta. I've seen many students. They say, oh, 2 doesn't matter. It doesn't matter. Just shift it a little bit down. The whole formula changes. And in one equation you have 2g for the maximum height. In the other two you have g. Be careful. These formulas are not on the formula sheet. They are not on the formula sheet. Should I add these 3 onto the formula sheet? I know the answer. Don't tell me. Okay, I'll put it on here.
So, like, for instance, if you have...
Is that the formula for range? And we're trying to say x must be maximum, right? For a particular velocity. So what are the constants? Velocity is a constant. G is a constant. The only thing you can change is the angle. So if you want x to be maximum, definitely sine 2 theta should be maximum. And the sine of an angle has a maximum value of 1. And that happens when the angle becomes 90 degrees. And in this case, the angle is 2 theta. So 2 theta should be 90 degrees for sine 2 theta to be 1, right? Therefore, theta should be 45 degrees. So I proved that the maximum range is obtained when you project something at 45 degrees. Next, I'm going to show that there are 2 angles to obtain a certain horizontal distance. And they're called complementary angles. What do you mean by complementary angles? You add them up, you get 90 degrees. So you will get the same range for 20 degrees and for 70. 20 and 70. 30 and 60. I know a lot of math. 45 and... Oh, that's a special angle. You get maximum for that, and that's the only angle, right? Okay, how do you prove it mathematically? That you have, you notice the difference between college physics and university physics now, Julie? Okay. Didn't have to say anything like this in college physics. That's right. I don't like to teach that class. I can't do any explanation. Just give me the formulas. Okay, anyway, so this is my best class. It is always. How do you, what's the formula? What's the formula? What are we talking about? Okay, so write that. X is equal to b squared sine 2 theta 1. I'm assuming there are 2 angles. I'm assuming. So, and I'm saying, okay, for the same velocity, I have another angle. So I call it theta 2. Well, gee, I just assumed. Is that what we do in math many times? Just assume there are 2 angles. Okay. And then cancel out the g's, cancel out the velocities. Don't cancel out the other 2, please. And then you go and become crazy. Do you know that sine of an angle will be the same as sine 180 minus the angle? See all the math coming out. Put it in your calculators. Find sine 30 degrees and find sine 150 degrees. Find both. Sine 30, sine 150. Check it out. Is it the same? Some people are saying, we know this. What are you trying to do? Did you get it? Hey, make sure your calculators are in the degree mode. If you have it in the radian mode, you're going to get crazy stuff. So that's what I wrote now. Is this meaningful? In place of sine 2 theta 2, I can write sine 180 minus that angle, because sine 30 is the same as sine 180 minus 30. Don't be dirty. Just look here. 180. You got it? Now it's easy. Just cancel out the signs. And what do you have? Nothing. 2 theta 1 plus 2 theta 2, when you take it to the outside, is equal to 180. Simple. So theta 1 plus theta 2 is 90. So there are two angles for a particular velocity to get the same horizontal distance. Ready? That's the formula. Oh, I put it as R, range. So sine 2 theta is that. Isn't that how you did it? Sine 2 theta is Rg by V naught squared. Substitute the numbers. You get 0.4239. So 2 theta is sine inverse of that. Again, your calculators must be in the degree mode. And you get 13 degrees. Well, I approximated 13 degrees and 77 degrees. Oh, yeah, I forgot. Thank you. Thank you. Yeah. But I did calculate it, right? I forgot to write it. Yeah.
If it's close like that.
Oh, you will get full credit. You get 110, no, 100%. And can you sketch the trajectories? Can you sketch how that'll look like? One is at 13 degrees, so 13 degrees should be really down like that. 13 degrees. And the other is 77. Wait.
You're going to want us to sketch a trajectory.
Yeah, because the question says, yeah, sketch it. Do you see that the horizontal distance is the same for both?
Would that be fine like that, or do you want an angle representing
Anyway. But this would be better because it shows perfectly that the horizontal distance is the same. Did you notice that the heights, maximum heights, are not the same? What about the time of flight? Will it be the same? The time of flight. Let me get you on this. Will the time taken for both be the same? Never. So the times are different, the heights are different, but the range is the same.
What is the value of
45, 24. Looking at the vertical components. Initial velocity, I put it as VOY. You know why, right? VOY is 0, A is 9.8, Y is 45. I want you to find the time. All right, use the king. That's the equation. Substitute. Of course, the first term is 0, so you have half times 9.8 times t squared, blah, blah, blah. Just calculate. You get the time as 3.03 seconds. And then you go to the horizontal. We know that the horizontal velocity is a constant. Therefore, the only equation you can use is velocity multiplied by time gives you horizontal distance. Therefore, you divide 24 by the time to get 7.92 meter per second. That's the diagram. I wish everybody had got that. Did you? That's the x. X is 75 meter. Vox is 180 meter per second. You can find the time using x's Vox times t. Divide and you get the time as 75 by 180. How much is that? 0.42 seconds. So that's the time. And then I did not list the variables down because by now you would know what they are. You're looking for y, isn't it? And V of y is 0. Therefore, half times 9.8 times 0.42 squared will give you 0.85 meter.
That's why I was confused because I kept plugging it into 0 and I was like, that doesn't make sense.
It makes sense.
No.
Makes us happy. This thing
that
becomes...
one, I kept plugging it and I was like...
It's the vertical velocity that is 0, not the horizontal.
Even before that, I was like, how are they... Okay.
Go to the second part of the question. What is the second part? At what angle should the gun be aimed so as to hit the target? Angle distance. That's what we've been talking about. Sine 2 theta is Rg by V naught squared. Plug in the numbers. And you get that. And then take 2 theta would be the sine inverse of 0.0226. Once you take the sine inverse, you get 1.3 degrees. But remember, that is 2 theta. So you got to divide that by 2 to get 0.65 degrees. All right, to find the maximum height, that's the formula. And you get 69.6 meter. When you plug in all those, I didn't bother to write it because all you got to do is just plug in the numbers, right? And then time is that, and the range is 405 meter. So to find the horizontal velocity, 65.2 cos 34.5. Did you get that as 53.7 meter per second? Yeah, and the vertical velocity, because I have to add my voice to it, I have to say it. Vertical velocity, we use that equation, and what did you get? 22.2 is there. Okay, 22.2, and then you took the resultant of the two. What was your final answer?
58.1.
Okay, so you squared both up. Okay, there it has come. Square both up, add them up, and you got 58 point, did you get 58.2? 8.1 meter per second, isn't it? Okay, 58.1 meter per second. And so now we are on, that is the diagram. Okay, let me slow it down. 75 meters. She swims at 0.45. That's why Vy is 0.45. Vx is 0.4 meter per second, and we do not know x, isn't it? Okay, like I told you, x is Vx times multiplied by time, y is Vy multiplied by time, and time may not be exactly how I told you that I thought about in that time, during that time. So I decided to find the time first, okay? Decide the time. I found the time, and that is 170 seconds is what she's going to take. And during that time, she's going to be carried downstream. The broken line shows you her actual path. I'm sure you understood that, did you? Because she's trying to go directly across. The water is carrying her down, so that's her resultant vector. So she's going to be 68 meters away from directly across. Well, we did B first and then we did A. Does it matter? It does not. Because the B question said how long will it take her to reach the other side, and A, how far downstream. So those are the answers. You understand? That is 260 meters? Right? Okay, that's it. That is 110 meters. Do you see that it's against the flow of the river? We'll go slowly. See, the water is flowing towards your, what is that direction? The west, isn't it? So isn't it 110 meters opposite to the direction of flow of the water? It is. Now tell me, what are those two vectors? What is this vector? What is this one? You mean 1, 2. One is the resultant of the velocities of the boat and the water. And what is 2? The velocity of the boat. Be with me. 2 is, that's the velocity of the boat. That's the direction the boat takes, 2. But because the water carries it down, you get the resultant as 1. Okay, I'm trying. Don't give me that blank look. The angle is 45 degrees. So you see that the angle is 45 degrees with the initial direction of the boat. Okay, but we do not know the angle at which it's going to end up. Now, the symbols, what do they stand for? Velocity of the boat with respect to the water. That's the actual velocity, isn't it? But velocity of the boat with respect to the shore will be the combined velocity, the resultant. Okay. And the other vector, I'm sure I wrote it, is velocity of the water with respect to the shore. Everybody with me? Water with respect to the shore. Okay, I'm trying. Can you find that angle? If you take tan theta, wouldn't you get it? Mm-hmm. Okay. So that angle, you can find that. Theta is tan inverse of 110 by 260. Now it's slow. Got it as 22.9 degrees. This is a very interesting part that I'll stop after I just write it. Okay. And everybody pay attention, because if you get this, you understand the problem. You ready? I want to show something. Watch. This. Everybody watching? Isn't that going to be VBS cos 22.9? I'll try one more time. Because you see two triangles. Don't you see two right angle triangles, one small and one big? And don't you see that that side is common to both the triangles? Oh, why should I be shouting like this? Isn't that side common to the small triangle and the big triangle? So can't I get that as either VBS cos 22.9 or VBW cos 45? That's what I'm doing. Got it? Okay, I hope so. So that's what I'm doing. So VBS cos 22.9 is the same as VBW sine 45. And so I can get VBS from that. Because everything else is known. So once you get that, I got it as 1.305 meter per second. You got the idea? Okay. Now take a look at, please, everybody, take a look at this. 1 second. I'll give you a chance. What is this side? What is this side? Isn't it VBS sine 22.9? Hello? Okay. What is this? Isn't it VBW sine 45? Sine and cos are the same. Sine 45 and cos. Okay. Both have equal numbers. So, is that clear? And if we get those two, don't we know that the difference between them is 110? Look at the board. So if you get the longer one and the shorter one is already 110, isn't it? So can't we find the...
Yes.
That's what I'm doing. I tried. Okay. That's the idea. VBS sine theta should be equal to VBW cos 45 minus. I gave you the idea, I've written it down. And when you go back home and look at it, you should understand. The rest is just math. And we get 0.7 meter per second as the speed of the water with respect to the shore. Isn't that what we were asked to find? Yes. So